Today what we're going to work on is section 4.5, proving angles are congruent by angle side angle and angle side. If you remember from the past sections, we would have sections, or we would have congruence by side, side, side. We would have side, angle, side, or we'd have HL. Today what we're going to do is we're going to add two more with angle, side, angle, and angle, side. So you're going to notice that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Really what that means is let's say I have this angle here and this angle here, and they're congruent and they're corresponding parts. And then I have a side, and then I have an angle. Notice that the side is included between the two angles, and so this would give me angle, side, angle. And so then I know that they are congruent. Let's take a look at a proof and see this in motion now. Line segment MN is congruent to line segment NO. I'm going to go given. And then I'm going to mark up my picture. I've got two more. Angle LN M is congruent to angle PNO, and that's also given. And I'm going to go and I'm going to mark that up. So I'm going to come over here, and this is congruent to this. I also have angle O and angle M are right angles. That's also given. You're going to notice it's in the picture and it's also there. And then on number 5, I'm going to go ahead and write my proof. LMN is congruent to triangle PON. And so I'm going to come over here and I'm going to write PON. Again, those letters are really important. They're order. So be really careful on that. All right. So based on my picture right now, I have a side and I have an angle. But the right angles don't do much for me. Now, normally if I have right angles, I go right away into the HL, but you're going to notice that my hypotenuses, which are here and here, they are not congruent and they are not touching. So that really doesn't do much for me. But what I can do is I know that they are right angles. So I'm going to come in here and I'm going to go angle O is congruent to angle M, and I'm going to write all right angles congruent. So if you have that sheet that I gave you in chapter 2 where we talked about proofs, you might want to look at that again and add this to it, that all right angles are congruent. That's one reason. And so now you're going to notice that these right angles have also been proven to be congruent. And so if I look at that, I've got my angle, I got my side, and I got my angle. So I'm going to come down here then and go angle, side, angle. All right, let's keep going. It says if two angles and a non-included side of one triangle are congruent to two angles and the same non-included side of another triangle, then the triangles are congruent. So an example would be, I've got an angle, and I'm going to do the angle here, and then I'm going to do another angle, and I'm going to do the other angle here. This would be considered angle, side. And so I would say triangle CDM is congruent to triangle PYT. And I can say that because of angle, side. All right, let's go down and take a look at this. I've got my given again, line segment X. I'm going to make this a little thinner. XQ is congruent to, I'm sorry, not congruent, parallel to TR. Okay, Notice that's up here in my given. It's right here. All right, I'm going to come over here and I'm going to write given. It also tells me that XR bisects QT. It's given. And so what I like to do on something like that is I got parallel. So if I got parallel, I can mark it up with my little arrows like I did in the past. And it says that XR bisects QT. So XR, I'm going to highlight that. That's kind of my indicator that it bisected that. And then I'm going to come down here and I'm going to go triangle XMQ is congruent to triangle RMT. And that's all that they gave me. So now I've got to try to figure this out. Now, one thing to take a look at is it says if parallel lines. Notice that they do it twice. Generally, if they do parallel lines and you are dealing with triangles, the next logical step would be if parallel lines, then alternate interior angles congruent. And I can do it on both. Because you'll notice it says if parallel lines. Now they gave me that, okay? So when I'm looking at these, what I want to do is I want to take a look at the parallel lines. Notice that this is parallel to this, and you've got two transversals. One of the transversals is XR, the other one is QT. And so I'm going to grab angle Q and angle T are congruent because of their alternate interior angles. And then angle X and angle R. Now notice that I'm naming those angles with only one letter. I can do that because there's only one letter there that makes that angle. You can name it with three, but you do not need to. Notice that because of what they did, I've got two angles and they are congruent. Now, what some students want to do is they'll want to do angle, angle, angle. They're going to go, oh, I see vertical angles. So I can go like this and I can go angle, angle, angle. Don't do that. Angle, angle, angle is not congruence. That is similarity, so I can't do that. But notice that in the problem, they gave me bisects. If they give you something like that, you are going to use it. And think about what bisecting means. It means cutting things in half. So I'm going to go MT, that line segment, is congruent to MQ. And the reason is going to be definition of bisects. So if they give you something like that, notice that they're going to use it. So this is congruent to this. And you're going to notice that you have angle, angle, side. So I'm going to come down here and I'm going to go angle, angle, side. You can also name it side, angle, angle. And this was my third point that I needed. Okay, sometimes we've got overlapping triangles. My advice to you is to pull them apart. If you can't see them, if you take a close look, here's my purple triangle here. And that is this triangle right here. Okay, and then the other triangle that they pulled apart is right here. And so this is pulled out here. So really important that you pull them apart, okay? They give you that BC then is congruent to CD. So those are congruent. And then AC is congruent to CE. And I can pull those apart. And then one thing that you can tell, and it's right here, angle C is congruent to angle C. It is reflexive. Notice that when we pulled it apart, this is one thing that they shared in common. So when I take it apart, those angle C's, they are still congruent to each other, and I can say reflexive. All right. So that is it for today. If you have questions, please let me know.